Welcome everyone to this presentation entitled How Modern Forensic Technologies Identify Remains from the Warship Vasa. Today I'll share how modern forensic science helped reconstruct the identities of several people who perished aboard the Swedish warship Vasa. First, a quick background on myself. I'm Brian Brunell and I'm the Senior Product Manager for myBaits and myTags at Dicel Arbor Biosciences. Previously, I conducted public health microbiology research. Pictures from a conference several years ago. I'm the one on the left. For the purposes of this webinar, I was asked to share my favorite study that used myBaits. So today I'd like to share with you a study from a presentation I saw at ISHI. ISHI is the annual International Symposium on Human Identification, and the talk was presented by Dr. Marie Allen, Professor of Forensic Genetics, Uppsala University. Please note, all work was performed by Dr. Allen and her colleagues, not Arbor Biosciences. The Warship Vasa was built between 1626 and 1628 as a flagship for King Gustav Adolphus of Sweden. Due to design flaws causing instability, the Vasa sank shortly after its maiden voyage near Stockholm. The wreck was salvaged in 1961, revealing remarkable preservation and archaeological finds, including human remains. The boat and many items are now displayed at the Vasa Museum in Stockholm, Sweden. Analysis from many different scientific fields were used to study the remains. Osteology estimated age, sex, stature, trauma, and disease. Isotope analysis revealed diet and origin, while archaeology studied clothing and personal artifacts for light contexts. DNA research predicted ancestry and physical traits. One of the DNA tools used was the myBaits Force Kit. The myBaits Force Kit uses hybridization capture to enrich approximately 5,400 forensically relevant markers from human DNA. This method works effectively with degraded and contaminated samples, enhancing historical forensic investigations. It is especially beneficial for almost 400-year-old DNA from skeletal remains contaminated with bacteria and fungi. Predicted traits from DNA analysis include sex inference, ancestry, facial features, eye and hair color, freckles, lactose intolerance, male pattern baldness, and more. Predicted reconstructions were made by the sculptor and archaeologist Oscar Nilsson using a combination of DNA phenotype, bone, and archaeological evidence. These sculptures can also be seen at the Vasa Museum in Stockholm, Sweden. Bone identification indicated remains from person G were male, and they were originally named Gustav. DNA analysis determined remains were female, and they've been renamed Gertrud. DNA data indicated sex, eye color, and hair color. The cap was found next to remains, which was incorporated into the sculpture. So, takeaways. Archaeological studies, in conjunction with osteological, DNA, and isotope analyses, provided information on remains from the 17th century. DNA analysis can help resolve kinship, but can also identify probable phenotypic traits. I found inspiring that many tools from various scientific fields, as well as many people, work together to restore identities lost to history. For more information regarding the Force Kit or to learn about other forensic DNA tools we offer, please reach out to us. I thank you for your time and attention.